Picture this, August 1944. While Allied forces storm the beaches of Normandy and push deeper into occupied Europe, a group of Nazi scientists are conducting secret meetings in a bunker beneath Berlin. They're discussing something that would change the entire trajectory of World War II if it had succeeded. Their project, a massive intercontinental rocket capable of striking targets across the Atlantic Ocean. Their target, the heart of America, New York City. This isn't speculation. This isn't Hollywood fiction. This is a documented Nazi weapons system so audacious, so ambitious, that military historians still debate whether Hitler genuinely believed it could work. It was called the V-4 rocket, and it represented the absolute apex of Nazi technological ambition. A final gambit to snatch victory from the jaws of defeat by striking an enemy that had never experienced foreign bombardment on their home soil. Today, we're exploring the true story behind Hitler's most dangerous secret weapon, the one that nearly brought the horror of mechanized warfare directly to American civilians. The concept of striking distant targets from across an entire ocean might seem like pure fantasy today. But during the Second World War, as conventional weapons proved increasingly inadequate for Nazi Germany's fading imperial ambitions, the regime's leadership began investing heavily in what they called Wunderwaffen, wonder weapons. These weren't merely advanced tanks or faster aircraft. These were revolutionary technologies designed to shift the entire balance of power in Germany's favor. Among these ambitious projects, few were as audacious, few were as scientifically complex, and few came as close to actual realization as the V-4 Intercontinental ballistic rocket. To understand the V-4, we must first understand its predecessors. The German rocket program began in earnest during the 1930s, when the Weimar Republic's restrictions on military development had finally lifted under Nazi governance. The primary architect of this program was Wernher von Braun, a brilliant aerospace engineer whose ambitions extended far beyond the narrow confines of Earth-based weapons. Von Braun dreamed of space exploration, of lunar missions, of sending humanity beyond the atmosphere itself. But in Nazi Germany, such ambitions could only be funded through military application. So von Braun, along with fellow scientists and engineers, began developing the world's first true ballistic missiles. By the early 1940s, this research culminated in the V-2 rocket, a marvel of engineering that could travel over 300 kilometers and strike targets with unprecedented accuracy. The V-2 was already shocking enough, a weapon that could be fired from German-occupied France and strike London, leaving defenders essentially powerless to stop it. Winston Churchill himself struggled to understand how Britain could possibly defend against such a weapon. Yet even as V-2 rockets began raining down on British cities in 1944, Nazi planners were already thinking bigger, much bigger. The V-4 represented a qualitative leap in ambition. Where the V-2 could strike targets in England from occupied France, the V-4 was designed to bridge the Atlantic Ocean entirely. The weapon was conceived as a true intercontinental ballistic missile, a rocket so powerful, so precisely engineered, that it could carry a warhead across the thousands of kilometers separating Europe from the eastern coast of the United States. The operational range being discussed in Nazi military planning circles was approximately 6,000 kilometers, more than enough to strike New York City, and potentially even Washington, D.C. The sheer technical challenges involved in such a system were staggering. Creating a rocket large enough to carry such a payload across such a distance required engineering solutions that hadn't existed before. The rocket would need to be exponentially larger and more powerful than the V-2. It would need a multi-stage design, with multiple engines working in carefully orchestrated sequence to accelerate the warhead across the Atlantic. The guidance systems would need to be far more sophisticated than anything previously developed. The precision required to strike a city from thousands of kilometers away seemed nearly impossible with 1940s technology. Yet the Nazi regime pursued the project anyway. In January 1945, Hitler himself was briefed on the V-4 program. The Führer, increasingly desperate as Soviet forces pushed closer to Berlin and American forces approached the Rhine, saw the V-4 as a potential miracle weapon that could force the Allies to negotiate peace terms. Imagine the psychological impact. Hitler's advisors argued, if a German rocket suddenly struck the heart of New York City, American public opinion would demand an immediate ceasefire. The entire Allied coalition might fracture under the shock of foreign bombardment on American soil. The concept wasn't entirely delusional. Germany had already demonstrated that it could develop and produce revolutionary weapons. The V-2 was being manufactured and deployed in growing numbers. The fundamental physics of long-range rocketry was understood. What Germany lacked wasn't necessarily the scientific knowledge, but rather the time, the industrial capacity, and the stability required to actually build and test such a weapon before the war ended. The Nazi regime, understanding this harsh reality, began investing enormous resources into the V-4 program despite the deteriorating military situation. Design work accelerated at multiple facilities across Germany. Engineering teams at Peenemünde, where the V-2 had been developed, began conceptualizing the massive V-4. The weapon was conceived to be nearly twice the size of the V-2, with a length exceeding 60 meters. Its payload capacity was designed to reach multiple tons, potentially enough for nuclear weapons development, which Nazi scientists were also pursuing, or for conventional high-explosive warheads of unprecedented destructive power. What made the V-4 conceptually different from simple V-2 enlargement was its proposed staging system. Early designs called for the rocket to initially be launched by a powerful first stage, which would then separate and fall back to Earth, allowing the remaining stages to continue accelerating the payload toward the Atlantic. This multi-stage approach was revolutionary for its time. The United States would eventually adopt similar staging concepts for its own ICBM programs in the 1950s, but the Nazi regime was developing these ideas during the darkest final months of World War II. The propaganda value of such a weapon was absolutely clear to Nazi leadership. Even if only a handful of V-4 rockets could be built before the war ended, striking American soil would prove to the world that Germany remained capable of fighting on. It would strengthen Hitler's position in negotiations. It might even trigger a political crisis in the United States, forcing American leaders to reconsider their commitment to an unconditional surrender policy toward Nazi Germany. Of course, by this point in the war, German military planning had become increasingly disconnected from military reality. The Soviet Red Army was advancing toward Berlin with overwhelming force. American and British forces were preparing to cross the Rhine and penetrate deep into German territory. The entire industrial and manufacturing base that had sustained Nazi Germany's war effort was being systematically destroyed by Allied bombing campaigns. Resources that might have been devoted to V-4 development were desperately needed to defend the German homeland against invasion. Yet the project continued. Scientists and engineers worked frantically, knowing that the war's end was approaching, but unable to stop the momentum of their research. By March 1945, just weeks before Germany's final collapse, V-4 design work was still proceeding. Multiple competing design concepts were under development. Some proposals called for submarine-based launch platforms, with V-4 rockets being fired from German U-boats lurking off the American coast. Other concepts involved ground-based launch facilities in remote areas of occupied territory, though finding such areas became increasingly impossible as Germany's territorial control shrank by the week. The technical specifications being discussed for the V-4 give us insight into Nazi ambitions. Design studies indicated that the rocket would utilize liquid-fueled engines burning alcohol and liquid oxygen, much like the V-2. However, the amount of propellant required was staggering, literally hundreds of tons. Manufacturing and transporting such quantities of fuel would have posed enormous logistical challenges, even if Germany's industrial base hadn't been in complete collapse. Guidance represented another critical challenge. The V-2 used a guidance system based on accelerometers and sophisticated mathematical calculations, combined with predetermined flight profiles. For the V-4 to hit a target thousands of kilometers away, the guidance system would have needed to be dramatically more sophisticated. Some Nazi proposals called for using radio beams to guide the rocket, similar to systems being developed for late-war fighter aircraft. Other proposals involved gyroscopic systems with unprecedented accuracy. The technological sophistication required was astonishing for the era. Warhead design created additional complications. A nuclear warhead was theoretically possible, given German progress in atomic physics, but such weapons were still purely theoretical in 1945. Conventional warheads would need to be incredibly destructive to justify the enormous resources required to build and deliver the V-4. Nazi engineers proposed warheads weighing several tons, filled with high explosives or potentially chemical or biological agents. The very concept of such a weapon represented a fundamental shift in warfare, a system that could deliver unprecedented destructive power anywhere on the planet, with the target having no meaningful defense. The Nazi regime understood that even if the V-4 program succeeded beyond all expectations, only a handful of rockets could possibly be manufactured and deployed before the war ended. They weren't planning to destroy American cities with a massive rocket bombardment campaign. Rather, they were counting on the psychological and political impact of even one or two successful strikes. Hit New York once or twice with a German rocket, Hitler's leadership reasoned, and American public opinion might shift dramatically. The shock, the humiliation, the obvious vulnerability of the American homeland might be enough to force a political change in Washington. This strategy was based on a fundamental miscalculation about American resolve and political culture. Hitler, who had never truly understood the democratic societies he was fighting, believed that Americans were soft, materialistic, and unwilling to endure hardship for abstract principles. He thought that the Blitz couldn't break British morale, and so presumably economic self-interest might break American determination. But this assessment was profoundly wrong. Even if V-4 rockets had struck New York, even if they had killed thousands of Americans, the result would almost certainly have been increased American fury and determination, not a collapse of American will to continue fighting. The V-4 program proceeded despite these strategic misconceptions and the obvious practical impossibilities facing the German war effort. By April 1945, with Soviet tanks rolling toward Berlin and American forces pushing deep into Germany from the west, some elements of the V-4 program were relocated to remote areas in the Alpine regions, attempting to continue research even as the Third Reich collapsed. Nazi leadership, trapped in their bunker beneath Berlin, still discussed wonder weapons and miraculous reversals of fortune, disconnected from the reality that Germany had lost the war beyond any possibility of recovery. The program came to an abrupt end with Germany's unconditional surrender in May 1945. Allied forces, knowing about Nazi wonder weapons programs from interrogated prisoners and captured documents, began sweeping operations to secure any remaining rocket researchers, hardware, and documentation. The Americans were particularly interested in these materials, understanding that rocket technology would become crucial in the emerging Cold War against the Soviet Union. Soviet forces also prioritized capturing German scientists and rocket specialists. Indeed, much of the Soviet Intercontinental ballistic missile program that would later threaten America was partially founded on German rocket technology and German scientists who fell into Soviet hands. Meanwhile, American forces secured Wernher von Braun and many other key members of the German rocket program, incorporating their expertise into American military space programs. The V-4 rockets themselves never flew. No prototypes were ever completed. No test launches took place. The weapon remained purely theoretical, a concept on paper and in engineering drawings. Yet the fact that the Nazi regime was even conceptualizing such weapons, devoting resources to them even as the war was being lost, tells us something profound about totalitarian warfare in the 20th century. The V-4 represented the absolute limit of technological ambition married to military desperation, a moment when a dying regime reached for impossible weapons in hopes of snatching miraculous victory from inevitable defeat. In many ways, the V-4 story is the story of Nazi Germany itself in miniature. Tremendous technical sophistication, incredible ambition, innovative thinking about weapons and warfare. Yet all of it ultimately subordinated to a political and strategic vision that was fundamentally disconnected from reality. Hitler believed he could conquer the world through will, through military force, through faith in the superiority of German science and engineering. The V-4 represented that worldview in its purest, most desperate form. After the war, the V-4 became something of a legend. Conspiracy theorists and alternate history buffs have speculated wildly about what might have happened if Germany had successfully deployed V-4 rockets against New York. Some accounts have wildly exaggerated the capabilities of the weapon system. suggesting that Germany was on the verge of actually striking America just as the war ended. Hollywood has seized on the V4 story, incorporating it into various science fiction and alternate history narratives. The weapon has become a symbol of Nazi ambition, a testament to what the regime might have accomplished with a few more years and a few more resources. Yet the historical reality was far more mundane and far more instructive. The V4 was never built because Germany lacked the industrial capacity, the time, and ultimately the resources to actually construct such a system. German physics and engineering, while sophisticated, couldn't overcome the basic constraints of a nation fighting a two-front war against vastly superior enemies. The V4 remained a dream, a concept, a moment of desperate hope in the final days of the Third Reich. The true legacy of the V4 was not in weapons it never fired, but in the technological knowledge that it represented. The basic concepts that German scientists developed for intercontinental ballistic missiles became the foundation for both American and Soviet ICBM programs in the Cold War. The American Atlas and Titan missiles, the Soviet R-7 and later systems, all benefited from German rocket research. In a cruel irony, the weapon that Hitler hoped would strike America became the technological foundation for weapons systems that would eventually threaten America far more significantly than the V4 ever could have. The scientists and engineers who worked on the V4 program had complex relationships with the Nazi regime. Some were genuine believers in German triumph, convinced until the very end that wonder weapons would save the nation. Others were apolitical technicians, interested only in solving complex engineering problems and unconcerned with the moral implications of their work. Still others were gradually becoming aware that they were serving a regime engaged in unprecedented crimes against humanity. Wernher von Braun, the leading figure in German rocket development, would eventually claim that he was apolitical, that he was merely interested in rocket science and space exploration, and that he had tried to minimize his entanglement with Nazi ideology. There is some truth to this claim. Von Braun's primary passion was indeed space technology. But he also held a commission in the Nazi SS, and he directly benefited from Nazi persecution of Jews, who were systematically excluded from scientific and technical positions. The moral complexity of von Braun's life and career would continue to haunt him long after the war ended. Other scientists involved in the V4 program had different experiences. Some were true believers in Nazi ideology, convinced that they were serving a great and noble cause. These individuals often experienced profound psychological crises when Nazi Germany's crimes were revealed after the war. Others who had harbored doubts about the regime but had participated in its military research programs would spend decades struggling with guilt and complicity. The existence of the V4 program tells us something important about how even desperate regimes continue planning for military advantage right up until the moment of final collapse. Hitler could have ordered a complete shutdown of research programs and devoted every possible resource to defensive measures against advancing Allied armies. Instead, he continued investing in future weapons, in strategic systems designed for wars that would never be fought, in technologies that would only benefit his enemies if they succeeded in capturing the research. This disconnect between military reality and strategic imagination became increasingly pronounced in the final year of World War II. The V4 was only one of many wonder weapons being pursued. There were plans for jet engines that would revolutionize fighter aircraft. There were designs for new tank systems. There were concepts for guided bombs and precision munitions. There were even plans for biological and chemical weapons. The regime threw resources at all of these projects, no matter how impractical, because Hitler believed in will, in vision, in the power of imagination to overcome material constraints. The V4 is particularly interesting because it represents the absolute outer limit of this technological optimism. It wasn't simply an evolution of existing weapons systems. The V2 already represented a revolutionary leap in military technology, the first true ballistic missile. The V4 would have required another revolutionary leap, combining innovations in rocket propulsion, guidance systems, staging mechanisms, and warhead delivery that were all being pioneered for the first time. In a military context where Germany had unlimited time and unlimited resources, the V4 program might have eventually succeeded in producing a functional intercontinental ballistic missile. The basic physics was understood. The engineering challenges, while formidable, were not impossible. German scientists had already demonstrated their ability to innovate and solve complex technical problems. But Germany didn't have unlimited resources. By early 1945, the German economy was in complete collapse. Industrial output was plummeting despite the regime's attempts at total war mobilization. Raw materials were scarce. Fuel was rationed. Transportation networks were being systematically destroyed by Allied bombing. Skilled workers were being conscripted into the military. The entire infrastructure required to support weapons development and production was crumbling. Against this background, devoting significant resources to a weapons system that couldn't possibly be completed and deployed in time to affect the war's outcome seems almost incomprehensibly delusional. Yet delusional is precisely what parts of Nazi leadership had become by this point. Hitler, increasingly isolated in his bunker, surrounded by yes-men and sycophants, had lost touch with military reality. He would issue orders for military operations with forces that no longer existed. He would confidently assert that new technologies would save Germany, even when those technologies existed only on paper. He would make strategic decisions based on what he hoped would happen rather than on what was actually possible. The V4 program was perfectly suited to this environment of desperate fantasy. It was just scientifically sophisticated enough to sound plausible. It was just ambitious enough to capture the imagination. It was just the kind of thing that an innovative, technologically advanced nation might pursue. But it was also just impossible enough that it perfectly embodied the disconnect between Nazi imagination and Nazi reality. Some historical accounts have speculated that if Hitler had survived the war, if he had escaped to Argentina or some other remote location, he might have tried to continue the V4 program in exile, with German scientists and perhaps financial backing from sympathetic industrialists. This is almost certainly fantasy. The V4 would have required industrial capacity far exceeding what would have been available to any post-war Nazi remnant. But it does illustrate how the V4 had captured imaginations, how it had become a symbol of what might have been possible under different historical circumstances. The V4 story is also significant because it highlights the dangers of technological overconfidence. The Nazi regime, despite its catastrophic strategic and moral failures, maintained a genuine belief that technology could save it from military defeat. This belief persisted even as objective evidence accumulated that the war was lost, that no amount of new weapons would change the fundamental equation of German forces fighting against the combined industrial and military power of the United States, the Soviet Union, and Great Britain. This pattern of technological overconfidence has appeared again and again throughout military history. Governments have repeatedly believed that a new weapon, a new technology, a revolutionary innovation would provide the decisive advantage that would allow them to achieve victory against superior forces. Usually, these hopes have been disappointed. The Maginot Line was supposed to make France immune to German invasion. Japanese planners believed that the Zero fighter would give them air superiority over the Pacific. The Americans believed that strategic bombing would break German morale and industrial capacity without requiring a ground invasion. In almost every case, the new technology that inspired such confidence turned out to be less revolutionary in practice than anticipated in theory. Defensive systems adapted. Enemies developed counter-strategies. The friction of war, the confusion, the chaos, the unexpected consequences intervened to complicate technological advantages. The V4 would almost certainly have followed this pattern if it had ever been tested in combat. Even if Germany had managed to strike New York with a V4 rocket, the weapon's strategic impact almost certainly would have fallen far short of Nazi expectations. The other significant aspect of the V4 program was its connection to the broader Nazi research effort into wonder weapons. The regime was pursuing numerous technological innovations simultaneously, often with insufficient coordination between programs. Resources were being spread across too many projects, preventing any single program from receiving the sustained funding and scientific focus that it needed for success. This fragmentation reflected broader problems with Nazi governance and military organization. The regime lacked unified command structures and was prone to bureaucratic infighting between various military and civilian agencies. The V4 program would have benefited from much greater institutional support and coordination. Instead, It competed for resources with the V-2 program, which was actually producing weapons and achieving at least some tactical success. The V-2's very existence as an operational weapon system gave its development program priority within Nazi planning. The V-4, remaining purely theoretical, could be sacrificed in the competition for resources. This brings us to an interesting historical question. What would have happened if the V-4 program had received greater priority? What if Hitler had ordered a complete shutdown of all other weapons development programs and focused everything on creating a single intercontinental ballistic missile that could strike New York? Even in this scenario, the answer is almost certainly that the war would have ended before the V-4 could have been deployed. The German military situation was deteriorating with such rapidity that by early 1945, shortening the war's conclusion by even a few months would have prevented the V-4's deployment. Soviet forces were advancing rapidly from the east. American forces would soon be crossing the Rhine and pushing toward Berlin. The German government itself was in chaos, with various factions competing for influence and resources. Moreover, even if Germany had managed to maintain territorial control long enough to actually launch a V-4 rocket toward America, the weapon's first test launch might well have failed. Developing new weapon systems is extraordinarily difficult, and first tests frequently reveal problems that require further development and refinement. The V-2 had required numerous test launches before reaching operational status. The V-4, being far more complex, would certainly have required extensive testing. Germany didn't have time for that testing program, so the V-4 remains a fascinating historical artifact, a dream of what might have been, a testament to human ambition and technological creativity, but ultimately a weapons system that never existed and never could have existed given the actual historical circumstances of World War II. It's a powerful reminder that even brilliantly talented scientists and engineers, when working within the constraints of a failing state and a failing military, cannot overcome fundamental historical forces through technology alone. The V-4 program had several competing design proposals, each representing different engineering philosophies and different assessments of what was technically feasible. One prominent design proposed a rocket that would be approximately 65 meters tall, taller than a 20-story building. The rocket would need to be massive not only in height, but also in diameter, with a core body perhaps 3 to 4 meters wide, allowing it to contain the enormous quantities of propellant required to achieve intercontinental range. The structural design of such a massive rocket presented formidable challenges. The V-2, while impressive, was relatively slender and compact. The V-4 would need to be far larger, yet also maintain structural integrity and aerodynamic stability throughout its flight. German engineers, drawing on experience from aircraft design and construction, proposed using advanced aluminum alloys and precision welding techniques. The production of such a massive vehicle would have required completely new manufacturing processes and factory facilities that simply didn't exist in 1945 Germany. The engine design represented another critical challenge. The V-2 used a single engine producing roughly 25 tons of thrust. The V-4, to achieve intercontinental range, would need engines producing hundreds of tons of thrust, either through a single massive engine or through a cluster of multiple engines working in coordination. German engineers had experimented with clustered engine arrangements, but never at the scale required for the V-4. Creating engines capable of producing such tremendous power, and then reliably coordinating multiple such engines to fire simultaneously and with equal thrust required technology that was genuinely beyond 1940s capabilities. The propellant management systems for the V-4 would have been extraordinarily complex. The V-2 used ethanol alcohol and liquid oxygen as propellants. The V-4 would use similar propellants, but in vastly greater quantities, managing the flow of hundreds of tons of propellant through valve systems, ensuring that the right mixture reached the engines at the right pressure and temperature, preventing cavitation and other fluid dynamics problems. All of this required sophistication beyond what had been previously achieved. The guidance systems for the V-4 represented perhaps the greatest technical challenge of all. The V-2's guidance system used an inertial navigation approach, with accelerometers measuring the rocket's acceleration and mechanical integrators calculating velocity and position. For a V-2, which had a range of roughly 300 kilometers, the accumulation of measurement errors remained manageable. A V-4 with a range of 6,000 kilometers would accumulate measurement errors that could easily be dozens or even hundreds of kilometers by the time the warhead approached its target. Various solutions to this guidance problem were proposed. Some designers suggested using radio beams transmitted from ground stations to guide the rocket toward its target. This approach had the advantage of being tested, as it was being used in late-war German fighter aircraft control systems. However, it had the disadvantage of requiring the rocket to maintain radio contact during its flight, which meant following a predetermined flight path rather than being able to maneuver in response to unexpected conditions. Other designers proposed using astronomical navigation, having the rocket measure the positions of stars during its flight to correct for navigational errors. This was a fascinating idea, in some ways anticipating concepts that would be used in later space programs. However, the technology to implement celestial navigation in a guided missile during the 1940s was extremely primitive. The sensors and computational systems required would have been enormously complex and heavy, potentially exceeding the rocket's payload capacity. Still, other proposals suggested incorporating a human pilot into the warhead vehicle itself, with the pilot being responsible for final guidance toward the target. This was essentially describing a manned aircraft system, but with a rocket providing the initial acceleration. It was a fascinating concept, but the survival of a pilot returning to Earth would have required a parachute system that would have consumed significant payload capacity. The reality was that no truly satisfactory guidance solution existed for an intercontinental ballistic missile in 1945. This wasn't a limitation of German engineering or German physics. It was simply that the technological foundation for such systems didn't yet exist. The United States would not develop reliable ICBM guidance systems until the late 1950s, using computational technology and manufacturing capabilities far exceeding what was available in 1945. The Soviet Union faced similar challenges and delays. The warhead design for the V-4 presented additional considerations. A single large warhead would have been simpler to implement than trying to deliver multiple smaller warheads, but the sheer size and mass of such a warhead would have been challenging. A conventionally armed warhead weighing several tons could cause enormous destruction when striking a city. But the engineering required to ensure that such a warhead detonated reliably after a journey of thousands of kilometers was non-trivial. Nuclear weapons represented another possibility, and Nazi scientists were indeed pursuing nuclear weapons research during the war. However, the German atomic program was substantially less advanced than the American Manhattan Project. Germany did not possess enriched uranium in the quantities required for nuclear weapons, and no German nuclear device had been successfully tested or even near to completion by the war's end. Using a nuclear warhead on the V-4 would have represented a dramatic escalation in the destructiveness of the weapon, but it would not have been a practical possibility in the actual historical timeline. Biological or chemical weapons represented yet another possibility for V-4 warheads. Nazi scientists were conducting horrific biological and chemical weapons research, and there were certainly individuals within the regime who would have been willing to deploy such weapons against America. However, weaponizing biological or chemical agents for delivery via rocket presented its own technical challenges. The warhead would need to be designed to disperse the agent effectively upon striking the target. Chemical agents could be dispersed through conventional explosives, creating an aerosol cloud of toxic material. Biological agents would require special handling to remain viable through the stresses of rocket acceleration and flight. The selection of launch sites for the V-4 represented another critical planning consideration. The rocket would be too large and complex to transport easily, which meant that launch facilities would need to be built relatively close to where the rockets were manufactured. However, as Allied forces advanced, finding suitable launch sites became increasingly problematic. Some proposals called for launching V-4 rockets from deep within German territory, using long-range ballistic calculations to reach targets across the Atlantic. Other proposals called for submarine-based launching systems, with V-4 rockets carried aboard specially designed U-boats. The submarine-based launch concept was particularly interesting from an engineering standpoint, but it presented extraordinary difficulties. U-boats would need to be specially designed to carry massive rockets and launch them, while remaining afloat on the surface of the ocean. The rockets, once launched, would need to achieve sufficient altitude to clear the submarine and reach their intercontinental trajectory. The entire system would be extraordinarily vulnerable to Allied air superiority. Any U-boat attempting to surface and launch a V-4 rocket would be immediately targeted by aircraft and naval forces. The infrastructure required to support a V-4 program would have been staggering. Manufacturing facilities would have needed to be built specifically for V-4 production, requiring enormous investment of raw materials, skilled workers, and machine tools. Test facilities would have been needed. High-altitude test stands to check engine performance, guidance system test beds to verify navigation accuracy, structural test facilities to ensure the rocket's structural integrity. Transportation networks would have been required to move massive rocket components from factories to launch sites. All of this would have required a functional German economy and a stable military-industrial complex. By early 1945, Germany possessed neither. The economy was in free fall. Industrial capacity was being systematically destroyed. The government was fragmenting. The military was being pushed back on all fronts. Raw materials were in acute shortage. Skilled workers were being conscripted into the military or killed in combat. The fundamental infrastructure that would have been required to actually build a V-4 rocket simply didn't exist, and there was no possibility of it being created before the war ended. The psychological and propaganda significance of the V-4 cannot be overstated. Even if only a handful of V-4 rockets could be built, successfully striking American targets would have represented an extraordinary psychological blow to the United States. For the entire history of the nation, Americans had been insulated from foreign military attack on their home territory. No foreign power had successfully bombarded American soil since the War of 1812. The American public had developed a sense of security, an assumption that geographical distance and American naval power meant that the homeland would never be seriously threatened. This sense of invulnerability would not be fully shattered until December 7, 1941, when Japanese forces attacked Pearl Harbor. That attack, while shocking and devastating, occurred at a distant American military base in Hawaii, not on the American mainland. The American public did fear Japanese attacks on the mainland. There were genuine concerns about Japanese submarines potentially launching shells against coastal cities, about possible Japanese invasion of Alaska or California. But no actual attack on American cities occurred during World War II. The V-4 represented a potential change to this pattern. Imagine the psychological impact if a German rocket suddenly struck New York City, the largest and most important American city, killing thousands and causing widespread destruction. American citizens who had experienced the war as something happening to foreign nations would suddenly become victims themselves. The war would move from distant battlefields to home territory. Hitler and his advisors believed that this shock might be psychologically significant enough to force changes in American policy. They theorized that the American public, upon experiencing foreign bombardment, might demand an end to the war. They might pressure their government to negotiate with Germany. They might demand a ceasefire, allowing Germany to consolidate its remaining territorial holdings in Europe. The V-4 in this analysis wasn't designed to win the war militarily. Germany would never win the war militarily by 1945. Rather, it was designed to create political opportunity through shock and dismay. This strategic analysis was fundamentally flawed, but it's important to understand the logic behind it. Nazi leadership had observed that the Blitz on Britain, while causing tremendous casualties and destruction, had failed to break British public will. But they theorized that America was different, more materialistic, more focused on comfort and safety, less willing to endure hardship for abstract principles. They believed that British resolve had been tested and had held firm, but American resolve had never been tested at all. They thought that might make the difference. This was a catastrophic miscalculation. American public opinion during World War II was firmly committed to defeating Nazi Germany. The attack on Pearl Harbor had unified American determination. American military industry was producing weapons at unprecedented rates. American soldiers were fighting and dying across multiple theaters of war. The American sacrifice was already tremendous, and the nation's leadership and public had firmly accepted that further sacrifice would be required to achieve final victory. If Germany had actually managed to strike New York with a V-4 rocket, the probable result would have been intensified American fury and determination, not a collapse of American will. American public opinion would likely have been outraged. American military leaders would have responded with massive retaliation, increasing the scale and intensity of bombing campaigns against German cities. American industrial capacity would have been directed toward developing and deploying rocket weapons systems of America's own. The strategic goal that Hitler hoped to achieve, forcing American negotiation and compromise, would almost certainly have been the exact opposite of what actually occurred. The V-4 story thus illustrates something profound about totalitarian regimes and their understanding of their enemies. Hitler fundamentally misunderstood American society. He believed he was fighting a nation of soft, comfortable people who would abandon the fight if struck hard enough. He failed to recognize the fundamental democratic commitment that had unified American society behind the war effort. He failed to understand that American sacrifice in World War II was driven by deep moral convictions about freedom and justice, not merely by comfortable material existence. This misunderstanding represented a failure not merely of intelligence or information gathering. Though the Nazi regime certainly lacked good information about American public opinion, but of imagination and empathy. Hitler could not truly imagine a nation that would endure hardship for abstract principles. He could not conceive of a population that would double down in commitment to a cause after suffering a terrorist attack. His entire worldview was predicated on conflict between national and racial groups pursuing material advantage and power. The idea that ideological commitment and moral conviction might be more powerful motivating forces than material comfort simply didn't compute within his framework. The V-4 represents, in miniature, the entire failure of Nazi Germany to understand and counter the forces arrayed against it. The regime possessed tremendous technological sophistication, incredible industrial capacity at the height of its power, and access to brilliant scientific talent. Yet all of these advantages were subordinated to a political and ideological vision so fundamentally distorted that it led inexorably to disaster. The V-4 was the apotheosis of this contradiction, the most technically ambitious expression of a strategic vision that was wholly disconnected from reality. The post-war fate of V-4 research materials and documentation remains somewhat unclear. As Allied forces swept through Germany, they captured enormous quantities of Nazi military research files. The V-4 documentation was among these materials. Some files went to American researchers, who incorporated the concepts into the developing American ICBM program. Soviet forces, as they advanced through Germany, also captured substantial quantities of German rocket research materials, and more importantly, captured German rocket scientists themselves. The Soviet Union would benefit enormously from German rocket expertise. Sergei Korolev, the brilliant Soviet chief designer of spacecraft and rockets, studied German V-2 rockets and Nazi rocket research extensively. The Soviet R-7 rocket, which became the foundation for the Soviet ICBM program and for all Soviet space launch vehicles, incorporated many design principles derived from the V-2 and from German rocket research. In a real sense, the intercontinental ballistic missile capability that would eventually threaten America during the Cold War was built on foundations laid by Nazi Germany's rocket program. This creates one of history's great ironies. The V-4 program, which was designed to strike America but never actually threatened America during the war, ultimately contributed to weapons systems that posed a far more serious and sustained threat to America during the Cold War. If American and Soviet scientists had been forced to develop ICBMs entirely from first principles, without access to German research, the development timeline would almost certainly have been extended. The technology that Nazi Germany developed, but could not deploy, became the technology that would, after the war, create the nuclear-armed missile systems that would dominate global politics for the next 50 years. The scientific and technical literature on the V-4 program has grown substantially in the decades since World War II. Historians and engineers have studied Nazi rocket research, attempting to understand what was actually being planned and what was fantasy. The consensus among scholars is that the V-4 was a real program with genuine scientific and engineering research being conducted, but it was also a program disconnected from military reality. Some historical accounts have treated the V-4 as a purely theoretical concept that existed only in the minds of enthusiastic Nazi planners and scientists. Other accounts have suggested that the V-4 program was substantially more advanced than has sometimes been reported, with some designs having progressed to detailed engineering studies and preliminary component testing. The truth almost certainly lies somewhere in the middle. The V-4 was real enough that significant research effort was being devoted to it, but not advanced enough that anything resembling a prototype rocket was ever constructed. The existence of the V-4 program was not a secret known only to Nazi planners. By early 1945, intelligence services in both the United States and Britain had become aware that Germany was working on rockets with intercontinental range. American intelligence agencies received reports about a New York rocket or a Washington rocket. Though the exact specifications described in these reports varied widely and often reflected the speculations of intelligence officers rather than hard facts about German programs. When American forces advanced into Germany and captured German military research facilities, they found extensive documentation about the V-4 program. Reports, design studies, technical specifications, and engineering drawings were recovered. These materials were studied intensively by American scientists and engineers, including Wernher von Braun and other German rocket experts who had surrendered to or been captured by American forces. The American ICBM program that would develop the Atlas and Titan missiles drew heavily on the conceptual work that German scientists had performed on the V-4. American engineers recognized that the basic concept of a multi-stage rocket capable of carrying a payload across intercontinental distances was sound, even if the specific German designs had not been perfected. They took the foundational work that German scientists had done, and with vastly greater resources and a larger industrial base, proceeded to develop functioning intercontinental ballistic missiles that would become operational in the late 1950s. It took American science and industry more than a decade, enormous expenditure, dozens of test failures, and the recruitment of German scientific talent to finally achieve what Nazi Germany had attempted during the war: the creation of a reliable intercontinental ballistic missile system. This tells us something important about the magnitude of the technical challenge that the V-4 represented. Even with all the advantages that America possessed, unlimited resources, industrial capacity many times greater than Germany's, and access to German scientific expertise, it still took more than 10 years to develop a functioning system. Had Germany succeeded in developing the V-4 during the war, it would have represented not just a military weapon, but a genuine scientific and engineering triumph. It would have demonstrated that the technological foundation existed for moving beyond planetary warfare to the development of space weapons, and eventually space travel itself. The fact that Germany came as close as it did to actually producing such a system, despite fighting for survival against overwhelming enemies, speaks to the genuine creativity and capability of German scientists and engineers. Yet it also speaks to the tragedy of totalitarian warfare. Brilliant minds, creative talent, and scientific innovation were directed not toward advancing human knowledge or solving human problems, but toward building weapons for a regime engaged in genocide. Many of the scientists working on the V-4 program were simultaneously aware of, or at least could have been aware of, the Nazi regime's systematic murder of 6 million Jews and millions of others. The moral cost of this scientific achievement under the shadow of such enormous evil cannot be separated from the technical achievement itself. After the war, many of the German scientists involved in the V-4 program and other Nazi weapons research faced questions about their complicity and moral responsibility. Some claimed that they had been apolitical, interested only in technical problems and unaware of or unaffected by Nazi ideology. Others acknowledged that they had known about Nazi crimes, but had rationalized their participation in weapons research as either necessary for survival or as a contribution to scientific advancement that might ultimately benefit humanity. Wernher von Braun, perhaps the most famous of the German rocket scientists, spent much of his post-war career attempting to rehabilitate his reputation and move past the moral complexities of his wartime work. He became an enthusiastic advocate for space exploration, presenting the peaceful promise of rockets and space technology to the American public through television documentaries and public appearances. He became closely associated with NASA's Apollo program, which put humans on the moon. Yet the shadow of his Nazi past never entirely disappeared. He had been a member of the SS. He had directly or indirectly benefited from Nazi persecution of Jews. The rockets that he developed for Nazi Germany killed tens of thousands of British civilians when V-2 rockets were launched against London and Antwerp. The moral complexity of von Braun's life reflects the broader complexity of scientific and technological advancement under totalitarian regimes. Science doesn't exist in a political vacuum. Scientists are citizens of nations, influenced by the political cultures they inhabit. Some German scientists actively embraced Nazi ideology and contributed their expertise enthusiastically to Nazi military programs. Others resisted or refused to participate in certain projects. Most occupied middle ground, continuing their professional work, telling themselves that they were simply scientists doing their jobs, while remaining willfully ignorant or choosing not to confront the uses to which their work was being put. The V4 program was thus, in many ways, representative of this broader pattern. Brilliant scientists working on extraordinarily complex technical problems, motivated by professional ambition and intellectual curiosity, while serving a regime that was simultaneously perpetrating some of the greatest crimes in human history. The V4 never became a weapon that actually harmed anyone. It remained purely theoretical, a design on paper, a moment of desperate ambition that never achieved material reality. But the trajectory of its development, and the fates of those who worked on it, illuminate the profound moral issues created when technological advancement becomes subordinated to totalitarian politics. As the war drew to a close in early 1945, the V4 program was being integrated into Hitler's increasingly desperate strategic planning. The Führer, now in his bunker in Berlin, was becoming progressively more detached from reality. He issued orders for military operations involving units that had been destroyed weeks earlier. He made strategic decisions based on wishful thinking rather than objective assessment of the military situation. He became convinced that new weapons, new strategies, new miraculous developments would reverse the course of the war. Within this context of spreading delusion, the V4 program represented both a genuine attempt to solve real strategic problems and a retreat into pure fantasy. Nazi military planners understood, at least at some level, that conventional military operations could no longer save Germany. The idea that a revolutionary weapon might change the equation at least had some internal logic to it. The idea that striking American soil with a German rocket might force a political crisis in America at least represented a coherent strategic concept, however flawed its assumptions might be. Yet by the time Hitler was being briefed on the V4 program, the war was already effectively lost from any rational perspective. Soviet forces were preparing the final assault on Berlin. American forces were crossing the Rhine and preparing to drive into the heart of Germany. German military forces were being pushed back on all fronts. The industrial and transportation infrastructure supporting the German war effort was in complete collapse. There was no possibility that the V4 program could be completed and weaponized before German military defeat became absolute and inevitable. The last weeks of the V4 program, like so many Nazi programs in the final days of the war, reflect the surreal nature of wartime administration in a collapsing state. Project officials continued writing reports and assessments even as their offices were being targeted by bombing raids. Scientists and engineers continued working on calculations and designs even as the sounds of artillery fire from approaching Soviet forces could be heard in the distance. Supply lines continued being requested and documented even though transport networks were completely broken. It was as if the bureaucratic apparatus of warfare continued operating through sheer institutional momentum, even as the reality that the apparatus was supposed to serve disintegrated around it. On April 20, 1945, Hitler's 56th birthday, the regime staged one last celebration in the Berlin bunker. Even as Soviet forces closed in on the city, Nazi officials attempted to maintain normal operations, staging propaganda broadcasts asserting that German resistance would continue. The V4 program was discussed in these final days. Even then, just days before Hitler's suicide, Nazi planners were discussing the possibility of relocating the V4 program to deep alpine valleys or to submarine bases where continued research might be pursued. On April 30, 1945, Hitler committed suicide. On May 7, 1945, Germany surrendered unconditionally. The V-4 program, like all Nazi military research programs, came to an abrupt end. Facilities were captured or destroyed. Documentation was seized by Allied forces. Scientists and engineers either surrendered to or were captured by Allied forces. The weapon that was supposed to threaten America never progressed beyond the design phase. The fate of specific individuals involved in the V-4 program varied widely. Some scientists died in the final days of the war, either in combat operations or due to Allied bombing. Some were captured by Soviet forces and deported to the Soviet Union, where they were forced to continue their rocket research work for the benefit of the Soviet regime. Others were captured by American or British forces and subsequently enlisted to work on post-war rocket programs, some willingly and others under coercion. The documents and hardware related to the V-4 program were scattered across several locations in defeated Germany. American forces secured some materials. Soviet forces obtained others. Some materials were lost in the chaos of the final days of the war. Historians have been piecing together information about the V-4 program for decades, attempting to understand what Germany had actually been planning and how advanced the program had actually become. The consensus among historians is that the V-4 program, while real and involving significant research effort, was substantially less advanced than Nazi propaganda sometimes suggested, and less fantastical than some post-war speculation suggested. The program existed, real designs were being developed, genuine scientific and engineering work was being undertaken, but no prototype rocket was ever built, no test launches occurred. The weapon remained a theoretical concept, a goal toward which Nazi scientists were working, but which they would never achieve. In this sense, the V-4 perfectly encapsulates the broader story of Nazi Germany's final year. The regime was pursuing increasingly ambitious and unrealistic goals, even as its fundamental situation deteriorated. It was throwing resources at projects that couldn't possibly succeed given the actual constraints of the military and economic situation. It was making strategic decisions based on hope and wishful thinking, rather than on realistic assessments of what was possible. The V-4 also serves as a reminder of the profound dangers of technological totalitarianism. Nazi Germany showed how a totalitarian state could mobilize scientific and technical talent toward military purposes with devastating effect. But it also showed how such mobilization, untethered from democratic oversight and truth-telling, could lead to catastrophic decisions. A democratic state would have to justify to a skeptical public and a suspicious legislature how it was spending enormous resources on a weapon system that couldn't possibly be completed and deployed. A totalitarian state faced no such constraints. Nazi planners could devote resources to the V-4 program with no one in a position to effectively challenge the decision, even as the objective situation made such expenditure increasingly irrational. The technology that Germany developed, but could not deploy, thus became the technological foundation for weapons systems that would shape global politics for the next 50 years. The Intercontinental ballistic missile, which emerged from the conceptual and technical work that Nazi scientists had performed on the V-4, became the defining weapon of the Cold War. American and Soviet missiles, each carrying nuclear weapons capable of destroying entire cities, would create a stalemate that lasted until the Soviet Union's collapse. A weapons system that was designed to serve a regime's desperate military ambitions in 1945, thus became the central feature of global geopolitics during the subsequent generation. The specific technical specifications proposed for various V-4 designs would have made the weapon truly formidable if they could have been achieved. Some design proposals called for a rocket capable of carrying a warhead weighing up to 5 tons across a distance of 6,000 kilometers. Others proposed even more ambitious specifications, with warhead capacities of 10 tons and ranges sufficient to strike targets across the Atlantic and potentially on the other side of the continent. To put this in perspective, the most powerful conventional bomb dropped during World War II, the British Grand Slam, weighed 10 tons and had to be carried by a specially modified aircraft. The idea of delivering several tons of conventional explosive across 6,000 kilometers using a rocket system represented an extraordinary step forward in the destructiveness of weapons that could be delivered remotely. If such a capability had actually been achieved, even in a limited form with only a handful of weapons actually deployed, it would have represented a genuine threat to American security. The vulnerability of the United States to such attacks would have been profound. At the time, American air defenses had no capability to intercept ballistic rockets approaching from above. The nation was accustomed to thinking of defense in terms of airfields and fighter aircraft. The idea of defending against rockets striking from the upper atmosphere, approaching at speeds measured in thousands of kilometers per hour, simply hadn't entered American military planning in any serious way. The post-war American military establishment, learning of the V-4 program and other Nazi research into intercontinental weapons, became convinced that the Soviet Union would pursue similar programs with even greater resources and determination than Nazi Germany had possessed. American military planners anticipated, correctly, that the Soviet Union would develop intercontinental ballistic missiles carrying nuclear warheads. This prospect became a primary driver of American military spending throughout the Cold War. In one sense, the V-4 program succeeded in its ultimate objective. The weapon itself never threatened America, but it convinced American planners that such weapons needed to be anticipated and defended against. American investment in ICBM development, in anti-ballistic missile research, and in nuclear weapons capability were all, at least in part, motivated by the possibility that enemies could develop weapons capable of striking America across intercontinental distances. The V-4, which never flew, thus influenced American military strategy for the next 5 decades. The legacy of the V-4 extends beyond military strategy into the realm of space exploration and civilian science. The rockets that eventually put Americans on the moon, and the rockets that have launched space stations and unmanned probes to explore the solar system, are in some real sense descendants of the V-4 program. The multi-stage rocket design, the liquid fuel propulsion systems, the sophisticated guidance mechanisms, all of these concepts that were pioneered by German scientists working on weapons systems have become the foundation for peaceful space exploration. This transformation of military technology into peaceful application is not unusual in the history of technology. Radar, developed initially for military purposes, became the foundation for civilian weather forecasting and air traffic control. Nuclear energy, developed for weapons purposes, became a source of civilian electricity. The Internet, developed initially for military communications, became the foundation for the World Wide Web and the information age. In each case, military funding and military urgency drove technological development that ultimately had profound civilian applications. The V-4 represents an extreme case of this dynamic. A weapon system designed to terrorize and kill American civilians became, after the war, the technological foundation for scientific endeavors that have advanced human knowledge and understanding of the universe. This transformation speaks to the ambiguity of technological change. The same technologies that can be used for purposes of destruction can be used for purposes of creation and exploration. The V-4 program also illustrates an important point about the nature of technological innovation under totalitarian regimes. Totalitarian systems can concentrate resources and direct them toward specific goals with an efficiency that democratic systems sometimes struggle to match. Nazi Germany, mobilizing its entire society for war, was able to achieve remarkable technical accomplishments in various fields. German scientists and engineers did make genuine advances in rocket technology, aircraft design, submarine construction, and various other military technologies. Yet the record of World War II also shows that this concentration of resources on military research, without the moderating influence of democratic oversight and scientific objectivity, often led to poor results. Resources were wasted on projects that were technically infeasible or strategically pointless. The regime's ideological commitments, such as the rejection of so-called Jewish physics and the purging of Jewish scientists from German universities, caused real scientific losses. The regime's embrace of pseudoscience in some areas led to resources being wasted on research that had no real scientific foundation. The V-4 program, while based on sound physics and genuine engineering expertise, took place within a political and military context that made success increasingly impossible. Removing the program from that context and placing it in the American system after the war, With unlimited resources, a functioning industrial base, access to the best scientific talent from around the world, and the time necessary to develop and test the technology, the program finally bore fruit. The rockets that were developed exceeded the specifications of the V-4 in some respects and fell short in others, but they represented the fulfillment of concepts that German scientists had pioneered. The cultural and popular memory of the V-4 has grown substantially in the decades since World War II. The weapon has appeared in numerous alternate history novels and stories, in which authors imagine scenarios where Germany actually managed to deploy V-4 rockets against American cities. These fictional accounts often portray the V-4 as being more advanced, more operational, and more threatening than the historical evidence actually suggests. Popular imagination has sometimes conflated the V-4 with other Nazi weapons programs, particularly the V-1 and V-2 rockets that were actually deployed. The V-1 was a cruise missile, a pilotless aircraft powered by a jet engine that could carry a bomb to targets in England. It was limited in range and could be countered by fighter aircraft. The V-2 was a true ballistic missile, but with a range of only about 300 kilometers, which meant it could strike targets in England and nearby areas but could not reach America. The V-4 was the intercontinental evolution of these weapons, and it has sometimes been portrayed in popular culture as being much closer to reality than it actually was. Some alternate history scenarios have imagined that if Hitler hadn't invaded the Soviet Union, or if Germany had negotiated peace with Britain, the nation could have continued developing the V-4 program until it actually became operational. These scenarios often portray the V-4 as a weapons system that was technically nearly complete, requiring only time and resources for final development. In reality, the V-4 was nowhere near completion, and no amount of additional time or resources would have changed the fundamental fact that the weapon was never going to be deployed during the actual historical timeline of World War II. The V-4 has also been portrayed in various science fiction and speculative works as the foundation for German space programs. Fictional accounts have described Germans launching satellites or even manned spacecraft using V-4 rockets if the war had ended differently, or if Germany had survived in some form. While the V-4 would indeed have been capable, if completed, of launching objects into space, the historical reality is that Germany never actually developed such a capability. What is historically accurate is that German rocket scientists and German rocket technology, appropriated by the Soviet Union and the United States after the war, did become the foundation for Soviet and American space programs. The Soviets launched the first satellite, Sputnik, using a rocket derived from the V-2. The Soviets sent the first human into space using derived rocket technology. American rockets, using German scientists and German concepts, eventually put humans on the moon. In this sense, the V-4 program, though never deployed as a weapon, did contribute to the peaceful exploration of space. The story of the V-4 thus encompasses multiple themes: the ambition and creativity of human engineering, the moral compromises of scientists working for totalitarian regimes, the ways that military technology developed for destruction can be transformed into tools for exploration and scientific advancement, and the fundamental limitations that history and circumstance place on even the most ambitious plans. The V-4 represents what human beings are capable of imagining, but also what they are sometimes prevented from actually accomplishing by the realities of history, the constraints of available resources, and the limitations of even the most advanced technology. In the final analysis, the V-4 remains one of World War II's most fascinating might-have-beens. Had Germany possessed more time, had the nation's military situation not been deteriorating so rapidly, had the entire infrastructure supporting scientific research not been collapsing, under those different historical circumstances, the V-4 might have evolved from a theoretical concept into a real weapon system. What would have happened if such a weapon had actually been deployed against American cities remains an interesting subject for speculation. But such speculation, while intellectually engaging, should not obscure the historical reality. The V-4 never flew, never threatened America directly, and never became anything more than a dream in the minds of scientists and planners working for a regime that was rapidly approaching its final collapse. The real significance of the V-4 lies not in what it actually accomplished, but in what it represented. It represented the absolute limit of technological ambition within a totalitarian framework. It represented the way that brilliant minds could be directed toward purposes of destruction. It represented the moment when even the most technologically sophisticated nation of its era attempted to reach beyond its grasp, to create weapons that its circumstances simply couldn't support. Most importantly, it represented the hope, however misplaced and ultimately futile, that technology alone could reverse the course of history. The lesson of the V4 is that technology, for all its power, cannot overcome fundamental limitations. A nation losing a war because it lacks the industrial capacity, the manpower, and the strategic position to compete with its enemies cannot be saved by a revolutionary weapon. A regime pursuing policies so fundamentally misaligned with human values that it has united the entire world against itself cannot escape its fate through engineering prowess. A military situation so deteriorated that enemies control the territory where weapons must be manufactured and tested cannot be salvaged through theoretical designs on paper. History is not determined by technology, but by the interaction between technological capability and human will, political strategy, economic resources, and the accident of circumstance. The V4 program illustrates this principle through the example of a weapon that was theoretically possible, that was based on sound physics and genuine engineering expertise. But that could never, given the actual historical circumstances of 1945, have become a functional weapon system. Understanding why the V4 failed tells us something important about the nature of warfare, the limits of technology, and the forces that actually shape historical outcomes. The scientific foundations of the V4 program rested on several decades of development in rocket science and ballistic theory. The earliest serious attempts to develop rockets for military purposes had occurred in various nations during the late 19th and early 20th centuries. But it was German scientists and engineers who took this research furthest, culminating in the development of the V2 rocket during the early 1940s. The V2 represented a quantum leap forward in military technology. It was the first truly successful ballistic missile, a weapon that followed a predetermined trajectory through the atmosphere, reaching altitudes of tens of kilometers before descending toward its target. The guidance system, while crude by later standards, was sophisticated enough to achieve reasonable accuracy at ranges up to several hundred kilometers. The V2 demonstrated conclusively that long-range rocket-based weapons were feasible, even if the specific implementation had significant limitations. The development of the V2 involved solving numerous technical problems that had never been addressed before in such a comprehensive way. The structural engineering required to design a rocket that would withstand the enormous stresses of acceleration was entirely novel. The thermodynamics of rocket engines, where fuel was burned in an extremely confined space at enormous pressures and temperatures, required new understanding and new calculations. The guidance systems represented a technological frontier, requiring the development of new types of sensors and new mathematical approaches to navigation. The success of the V2 program, while not complete, the weapon didn't arrive in sufficient quantities soon enough to change the course of the war, demonstrated that a systematic approach to advanced weapons development could achieve remarkable results. Nazi planners, seeing the V2 succeed, became convinced that even more ambitious projects could succeed if given sufficient resources and scientific attention. The V4 represented the logical extension of V2 development, a weapon that would incorporate all the lessons learned from the V2 program and extend the technology to reach intercontinental ranges. The scaling up from V2 to V4 would have required solutions to problems that were multiple orders of magnitude larger and more complex than those that had been solved for the V2. The structure of the rocket would have to be scaled up, but not proportionally. A rocket twice as large would require far more than twice the structural strength, because the stresses would increase with the size of the vehicle. The engines would have to be far more powerful, creating extreme challenges in fuel management and engine efficiency. The guidance systems would have to be dramatically more accurate, because errors that were tolerable across a range of 300 kilometers would be intolerable across a range of 6,000 kilometers. These escalating challenges would have required not just more funding and more scientific personnel, but genuine innovations in multiple fields. German scientists recognized that they would need to develop new materials capable of withstanding higher temperatures and stresses. They would need new alloys and new manufacturing techniques. They would need to develop more sophisticated guidance systems, including sensors and computational devices that didn't yet exist. They would need to solve problems in fluid dynamics, thermodynamics, and materials science that had never been addressed before. The fact that German scientists, even while the war was going increasingly badly, remained convinced that the V4 was feasible suggests something important about the nature of technological optimism. Scientists and engineers, confronted with complex problems, often develop confidence that these problems can be solved through sustained effort and adequate funding. This optimism is usually justified. Indeed, technological progress depends on this kind of optimistic belief that problems can be overcome. But in the context of the V4, this optimism was divorced from the political and military reality that Germany was losing a two-front war and had at most a few months remaining before complete defeat. The V4 program thus represents an interesting case study in the psychology of technological development under stress. The scientists and engineers involved in the program were brilliant individuals, educated in a rigorous scientific tradition and trained in rigorous problem-solving techniques. They could see, intellectually, that the V4 represented a feasible project if approached systematically and given adequate resources. What they apparently could not or would not see was that Germany would never have the resources or the time that the project would require. They continued the work, submitting reports and pursuing research, as if the normal functioning of German institutions and the normal patterns of military development would continue indefinitely. This disconnect between technical possibility and historical reality represents one of the tragic aspects of wartime technological development. The brilliant minds that Germany had assembled could have solved the V4 problem, given adequate time and resources. But neither time nor resources would be available. The German scientists were thus pursuing a goal that was simultaneously technically feasible and historically impossible. The comparison between the V4 program and other attempted superweapons of World War II illuminates what was distinctive about the V4. Germany pursued numerous ambitious weapons programs during the war, each one designed to provide the military advantage that would allow Germany to achieve victory. The jet-powered Me-262 aircraft represented a revolutionary advance in fighter technology. The Tiger tank was, at least in the early war years, the most heavily armed and armored tank in the world. Chemical weapons research programs were exploring possibilities for new, more effective poisons. Atomic weapons research, while less advanced than American efforts, was pursuing the possibility of nuclear weapons. What distinguished the V4 from these other programs was its ambition to affect the entire strategic equation through a single technological innovation. The Me-262, while a remarkable aircraft, couldn't win the war. It might improve German air defense against Allied bombers, but it couldn't change the fundamental balance of power in the air war. The Tiger tank, while formidable, couldn't achieve strategic victory. Tanks operate within the context of broader military campaigns, and no tank design could overcome German inferiority in manpower and industrial capacity. Chemical weapons might cause casualties, but they couldn't win a war against enemies prepared to retaliate with chemical weapons of their own. The V4, by contrast, was conceived as a genuinely strategic weapon. It was supposed to strike the enemy's home territory, the very center of American power, dealing a blow that might be psychologically significant enough to shift the political will of the American nation. This represented a fundamentally different conception of how a weapon system could affect war outcomes. Rather than trying to win through superiority in tactical engagements, or even in particular theaters of war, the V4 was supposed to win through achieving strategic shock, striking at something so fundamental and so important to the enemy that the enemy would be forced to negotiate. This concept of strategic bombing was already deeply embedded in World War II military thinking. The Allies had spent years developing long-range bombers specifically because they believed that striking at German industrial capacity, German morale, or German leadership could force Germany to surrender without the necessity of conquering German territory with ground forces. The Germans believed that long-range bombers striking at London could break British resolve. Now, in the final desperation of the war, the Germans were applying this same logic to rockets. If a rocket could strike New York, maybe American resolve could be broken. The fundamental flaw in this reasoning applied equally to V-4 hopes as to the broader strategic bombing campaign that the Allies were conducting. Strategic bombing of German and Japanese cities did not break the morale of the populations being bombed. Indeed, in many cases, bombing appeared to harden public resolve. The populations of bombed cities became, if anything, more committed to their nation's war efforts, not less. American planners would eventually reach similar conclusions, understanding that strategic bombing alone could not win wars. The V-4, based on the same flawed assumptions as the strategic bombing campaign, would have been equally likely to fail to achieve its strategic objectives if it had actually been deployed. But this failure of strategic assumptions is separate from the question of whether the V-4 could have been technically achieved. The weapon might have been strategically ineffective while still being technically feasible. The question that historians continue to debate is whether the V-4 could actually have been built and tested before the war ended. The conventional consensus is that it could not have been, because the technical challenges were too great and the time available was too limited. But there remains room for legitimate debate about whether a more massive commitment of resources, or different decisions about what other programs to shut down, might have allowed at least a prototype V-4 to reach the test stage before Germany's final collapse. The reality is that we can never know with certainty what would have happened under different historical circumstances. This is, in fact, one of the reasons why the V-4 continues to fascinate historians and the general public. It represents the ultimate historical might-have-been, a weapon that was theoretically possible, but that the actual circumstances of history prevented from becoming a reality. Speculating about what would have happened if the V-4 had been successfully deployed, or if Germany had managed to maintain territorial control long enough to complete the program, engages fundamental questions about history, technology, and human agency. What we can say with confidence is that the V-4 program represents one of World War II's most ambitious technological undertakings. It engaged the best scientific and engineering talent that Nazi Germany possessed. It was based on sound physical principles and genuine technical understanding. It represented a coherent, if ultimately flawed, strategic vision. And it ultimately failed not because of any fundamental flaw in the technological approach, but because history and circumstance intervened to prevent its completion. The V-4 thus stands as a monument to both the power and the limitations of human technological ambition in wartime. The final act of the V-4 program, like so many aspects of Nazi Germany's final days, played out in a context of surreal desperation and institutional denial. As Soviet forces launched their final assault on Berlin, as American forces advanced across Germany from the west, as the physical and industrial infrastructure of the Nazi state collapsed, project managers continued submitting reports and requesting resources for the V-4 program. It was as if the normal routines of military administration and research had become so deeply embedded in institutional practice that they continued operating through sheer momentum, even though the framework that gave them meaning had essentially ceased to exist. This phenomenon, the continuation of institutional routines even after the underlying reality that justified those routines has changed, represents an important insight into how organizations function under extreme stress. The people working on the V-4 program in April 1945 were, in many cases, individuals of genuine scientific and technical competence. They understood, at least at some level, that Germany was losing the war. Yet they continued the work anyway, because that's what they had been trained to do, because their careers and identities were bound up in the project, and because the alternative, acknowledging that their work was futile, was psychologically unbearable. The final documents of the V-4 program, recovered by Allied forces after the war, show a project that was continuing to develop concepts and make plans even as the war was entering its final weeks. Design studies were being completed, technical specifications were being refined, proposals were being made for manufacturing approaches and test procedures. Contingency plans were being discussed for relocating the project if the current facilities became unsafe. It was the product of minds attempting to maintain rational planning and systematic development, even as the entire context for that planning and development was disintegrating. When Germany surrendered, the V-4 program ceased to exist as a Nazi project, but it didn't disappear entirely. Rather, it was dispersed among the victorious powers. Allied forces, understanding the strategic value of German rocket expertise, moved quickly to secure German rocket scientists and to capture documents and hardware associated with German rocket programs. The Americans were particularly successful in this effort, managing to recruit Wernher von Braun and numerous other German scientists who had previously worked on the V-2 and would have worked on the V-4. The Soviet Union also obtained German rocket expertise, though in a somewhat different manner. Soviet forces, occupying eastern Germany, captured German scientists and technical personnel and deported them to the Soviet Union, where they were essentially compelled to continue their rocket research work for Soviet purposes. Many German scientists found themselves working in closed Soviet facilities, continuing the research that they had conducted for Nazi Germany, but now under Soviet supervision rather than German supervision. In this sense, the V-4 program did achieve a form of completion, though not in the way that its original architects had envisioned. The concepts that German scientists had developed for intercontinental ballistic missiles were taken up by both American and Soviet scientists. With access to German research, with the recruitment of German scientific talent, and with vastly greater resources than Nazi Germany had possessed, American and Soviet engineers proceeded to develop functioning intercontinental ballistic missiles that exceeded the specifications of the proposed V-4. The American Atlas and Titan missiles, developed in the 1950s, incorporated design principles that had been pioneered in the V-4 research. Multi-stage rockets, liquid fuel propulsion systems, guidance systems capable of achieving reasonable accuracy across continental distances. All of these elements that German scientists had been working on became fundamental features of American missile systems. In a real sense, the V-4 program was completed after the war, not by Nazi Germany, but by its victorious enemies who had appropriated its research and its scientists. The irony is profound. Hitler had hoped that a functioning V-4 would force America to negotiate peace with Germany. Instead, the V-4 program, having never achieved operational status under Nazi auspices, contributed substantially to weapons systems that would eventually threaten America far more seriously during the Cold War. The intercontinental ballistic missile, which emerged in part from German research, became the defining weapon of the nuclear age. The weapon that was supposed to achieve German victory became, after the war, a central component of the global military balance that would persist for the next 50 years. The story of the V-4 thus ends not with a dramatic moment of deployment or destruction, but with dispersal and transformation. The research materials were scattered among the victorious powers. The scientists were either recruited to continue their work for new masters or deported to nations they had never expected to work for. The weapon itself was never built, never tested, never deployed. Yet the concepts that underlay the weapon, the engineering principles, the scientific understanding, the technological innovations, those survived and prospered in a context entirely different from what their original creators had imagined.